On the method of partial fractions, suppose I ask you to calculate the integral of 4x squared minus 3x plus 2 divided by 4x squared minus 4x plus 3 dx. So as long as you have the same exponent on the numerator and the denominator, first you have to do long division. In the long division method, you have 4x squared minus 3x plus 2 divided by 4x squared minus 4x plus 3. So first of all, let us try 1. 1 times 4x squared minus 4x plus 3 goes down here, then you subtract it from your numerator. So you have 4x squared minus 4x plus 3, and then you do the subtraction. When you're doing a subtraction, here you have minus 4x squared plus 4x, and then you have minus 3. So when you do the subtraction, the new term or the new expression, 4x squared and negative 4x squared disappear. 4x minus 3x is x, and you have negative 3 plus 2, which is negative 1. Very good. So this is your remainder. What's the meaning of that? It means that this longer fraction, 4x squared minus 3x plus 2 divided by 4x squared minus 4x plus 3 can be written as 1 plus the remainder, which is x minus 1, divided by the denominator, which is 4x squared minus 4x plus 3. Very good. So now we can take the integral of both sides. The integral on the left is equal to the integral on the right. Then we are taking the integral with respect to x. Very good. Now, how do we deal with this integral? We have x minus 1 divided by 4x squared minus 4x plus 3. So take a look at your denominator. This integral is the integral of 1 dx plus the integral of x minus 1 divided by 4x squared minus 4x plus 3 dx. Can I complete the denominator? Is it possible to do that? Let us do a little bit of algebra. Try our best to write 4x squared minus 4x plus 3 into something simpler. Recall that if you have 4x squared minus 4x and plus 1, this is equal to 2x minus 1 to the second power. Well, this can be written as 4x squared minus 4x plus 1 plus 2, and I can take this part and write it in compact form. Very good. So this integral can be written as the integral of 1 dx, which is just x, plus the integral of x minus 1 divided by, now my denominator can be written as 2x minus 1 to the second power plus 2 dx. So how is it useful? Pay attention here. If I take u to be 2x minus 1, du is 2 dx. But from the first equation, 2x is u plus 1, or x is u plus 1 divided by 2. So this integral in turns can be written as x plus the integral of wherever I see x, I'm going to use u plus 1 divided by 2. So I have u plus 1 divided by 2, but it has a negative 1 on top as well, divided by u squared. Let me use the same color. U squared plus 2. And then I take the integral. So du is 2 dx. So my dx becomes du divided by 2 du divided by 2. Very good. So let us try our best to simplify this integral as much as we can. This in turns can be written as x plus the integral of, if I take common denominator up there, I get u plus 1 minus 2, or I get u minus 1 divided by 2. So you get du divided by 4. And on the denominator, I have u squared plus 2. Plus 2. Very good. So this integral in turns can be broken down into x plus 1/4 of the integral of u divided by u squared plus 2 minus 1 divided by u squared plus 2 du. Very good. We're going to use another u-sub here, everybody. This is x plus 1/4 of the integral of 2 u du divided by 2u du divided by, and I'm going to multiply it by a half. And down here, I have u squared plus 2 minus the integral of du divided by u squared plus, pay attention here, I'm going to use square root of 2 raised to the second power. And then close this off. So this integral in turns is x plus, if I distribute a fourth into parentheses, I get 1/8, the integral of, for example, dv divided by v minus the integral of du divided by u squared plus square root of 2 to the second power. And it has 1/4 in front of it as well. So this integral is x plus 1/8 ln of absolute value of v minus 1/4 times 1 over square root of 2. And then you have inverse tangent that we discussed before. Inverse tangent of u divided by square root of 2. Very good. So what was u? We need to go back and find our u. U is 2x minus 1. So just substitute it back here. You get x plus 1/8 ln of absolute value of u squared plus 2. This was my new sub. This was my v. I'm going to substitute it back here. And then for the rest of it, I get negative 1/4 times square root of 2 times inverse tangent of u divided by square root of 2 plus c. And then my final answer in x is x plus 1/8 ln of absolute value. Okay, 2x minus 1 to the second power plus 2 minus 1 over 4 times square root of 2 inverse tangent of 2x minus 1 divided by square root of 2 plus constant of integration. So in this question, we had long division. By doing long division, we could break this down into two partial fractions, but eventually we didn't break down the second fraction into smaller pieces. One of them was 1, the other one is x minus 1 divided by 4x squared minus 4x plus 3. And by continuously using U-Sub, we were able to simplify this integral into something that we saw before we feel comfortable applying.